All right, this is Unit 2, Lesson 3 for Geometry A. I want to go over a couple of concepts that give students a lot of trouble. These are the types of problems I find myself answering questions about or working with people on in this unit. And they are problems that involve writing and solving equations. The trouble I find is not necessarily with geometry often, but it is with the algebra. So in this class it is expected that you've taken algebra, but that doesn't mean necessarily that you have mastered algebra. And some of your algebra may be a little shaky. So this is a little bit of algebra review. I've got two problems I want to look at. Two kinds of problems, both involving writing and solving equations. So on the screen you see a line segment AC. And B is said to be the midpoint. B is the midpoint of segment AB. Note I'm using capital letters and the symbol for AB. Capital letters, line segment. All right. Midpoint means the exact middle, the exact center. It means that the measure of AB equals the measure of AC. So that's really the crux or the geometry part of this, that AB and BC. And note when I write AB without a line segment drawn above it, it means the distance between A and B. Okay, it's not object AB, it is the distance between or the length of AB. All right, so AB equals BC, and by substitution we can write 2x plus 7 equals 5x minus 5. And there's the extent of the geometry. We've done the geometry. The rest, so to speak, is algebra, and that's where for some of you the trouble begins. Of course, the first trick is recognizing that midpoint means the two halves are equal, and then writing an equation that says they're equal. Okay? So in algebra, you remember some basic fundamentals. 1, our object or goal is to get the x alone, get the x by itself. 2, we need to get rid of things to make that happen. 3, we do opposites to get rid of things. Okay, so opposites. If I want to get rid of a plus 7, I minus 7. If I want to get rid of a minus 5, I plus 5. If I want to get rid of a times 5, I divide 5. 4, we do things in reverse order. Okay, so normally PEMDAS would say I multiply before I add. Well, when I solve an equation, I get rid of addition before I get rid of multiplication. I work things backwards. Okay, now in this particular case, we have a bit of a problem. We've got an x on both sides. So we need to first take care of that even before we get to the undoing stage. And the way we do that is by getting rid of either the 2x or the 5x. Now there's no hard fast rule about which one to get rid of. I like to get rid of the smaller one. I like to maintain positive coefficients. So I'm going to get rid of the 2x, and I get rid of the 2x by doing the opposite of plus 2x. I'm going to minus 2x. Now the rule property of balance of equations says I need to do the same thing to both sides. So I'm going to subtract 2x from both sides. Okay? And I'm going to get, when I do that, as long as I do the same thing to both sides, I keep it balanced. I'm going to get 7 equals 5x take away 2x. If I have 5 x's and I take away 2 x's, naturally I have 3 x's remaining. 3x minus 5. So you see we've simplified the problem. Now we've gotten rid of one of the x terms, and we only have x on the right side. Okay? My son is being a little noisy in the background. I hope that's not coming too clearly on there. So now I want to get the x alone. So I'm going to get rid of the 3. I'm going to get rid of the 5. But opposite order says I'm going to get rid of the 5 first. So the opposite of minus 5 is plus 5. Balance says if I add 5 to the right, I need to add 5 to the left. Okay? And so 7 plus 5 is 12. And I have 3x, and negative 5 plus 5 is 0, and hence we have undone or gotten rid of the minus 5. Okay, now I need to get rid of the 3. I'm going to get rid of the 3 by doing the opposite of multiplying 3, which is dividing 3. And if I divide 3 on the left, I divide 3 on the right. 3 divided by 3 is 1. And 1 times x is x. And so we have, by dividing, gotten rid of the coefficient 3. 12 divided by 3 is 4. And so we can see that x equals 4. Now, the question might ask, find x. If that's the case, then we've done it. The question might also ask, find the length of AB, the length of BC, or the length of AC. In that case, here are some other steps. I can substitute 4 for x in both of these expressions. 2 times 4 plus 7. Now follow PEMDAS, multiply before add. 2 times 4 is 8. 8 plus 7 is 15. Okay, I can substitute 4 for x here. 5 times 4. 5 times 4 is 20. 20 minus 5 is 15. So I can answer the question, AB, the length of AB is 15. The length of BC is 15. I can even answer the question, the length of AC, the entire thing, is AB plus BC, right? AB plus BC, segment addition, or 15 plus 15 for 30. Okay? Hopefully that makes sense. All right, let's go to the second problem here. Second problem. Okay, second problem. Now in this particular problem, you'll notice that B is not the midpoint of AC. Okay, it's not in the middle, so I can't say AB equals AC, but I am told what the total length of AC is. I'm told, give an expression for AB, an expression for BC, and an expression for AC. In that case, I can write this expression, this equation. I can say that AB plus BC equals AC. That's the segment addition postulate, right? It says two segments that make up a segment can be added to find the length of the whole thing. Okay, so now by substitution, AB is 5x plus 3, 5x plus 3. BC is 15. And AC is 34. Now you might be tempted to put in, well, AC is 5x plus 3 plus 15, but then all we've done is recreate the same thing on the left. We have to have an alternate expression in order to be able to solve this. So AC is 34. Okay? And again, as before, the rest is algebra. So we need to simplify. We need to remember the principle is get the x alone, get rid of things by getting rid of things, get rid of things by doing opposites. And when we have an x on both sides, we get rid of one of the x terms. When we have multiple like terms, and that's what's happening here, we can combine those like terms. 3x or 3 and 15 are like terms. They don't have x's on them. They're known as constants. They can be added or combined. So 3 plus 15 is 18. So 5x plus 18 equals 34, and we've simplified. Now I'd like to get the x alone, so I'm going to get rid of the 5 and the 18, but reverse order says I'm going to get rid of the 18 first. Opposite of plus 18 is minus 18. Minus 18. Okay? And then I get 18 minus 18 is 0. All that's left is 5x. 34 minus 18 is 24. 34 minus 18. Did I do that right? Yeah, hopefully I did. 34 minus 18 is 20. Is 14, 15, 16. Yeah, I didn't set this up right. Make sure I did this right. 5x plus 3 plus 15 equals 34. 3 and 15 is 18. 34 minus 18, 34 minus 20 is 14 plus 2 is 16. Yep, we did it right. I just didn't set up the problem. I like to set up the problem so that we don't have decimals, but we're going to get a decimal here. So now I want to get rid of the times 5 by dividing 5 on both sides. Divide 5. Okay. Divide 5 on both sides. 5 divided by 5 cancels out, leaves 1, and 1x is x. So we get x equals 16 divided by 15. Doesn't go evenly. So we just divide using a calculator or using our heads. 15 divided by 5 is 3, so we have 1 left over. 1/5 is 0.2. So 3.2. Okay. All right, so as before, you might have been asked in the question to find x. If that's the case, we're done. But you might have been asked to find the length of AB as well. And in that case, substitution is the key. So always be ready to substitute. You don't always have to substitute. It depends on what the question is asking. Okay, 5 times 3.2 plus 3. 5 times 3.2. 5 times 3 is 15. 5 times 2 is 10. So 5 times 0.2 is 1. So that's 16. 16 plus 3 is 18. And we find that AB is 18. And just to check, AC should be AB plus BC. So AB is 18, BC is plus 15, and lo and behold, I get not 34. So what went wrong? 5 times 3 is 15. 5 times 0.2 is 1. 16 plus 3. 16 plus 3 is not 18. There we go. And that happens. And I like to model making mistakes. 16 plus 3 is not 18. So you're going to find you have to sometimes go back and figure out where you made your mistake. 16 plus 3 is 19. 15 plus 19. 19 plus 15 is 20, 34. There we go. And so it was a good thing that I checked, and that's a good way to make sure you get the right answer as well. So hopefully that helps. Feel free to book a live lesson if you need any more help.